looking at circle geometry, we are looking at circle theorems. We take the first theorem, which is theorem 1. Theorem 1 states that a straight line drawn from the center of a circle to bisect a chord which is not a diameter is at right angle to the chord. So we have that a straight line drawn from the center of a circle to bisect a chord which is not a diameter is at right angle to the chord. So we said the straight line which is drawn from the center of the circle to bisect a chord which is not a diameter is at right angle to the chord. So we'll attempt to prove this theorem. After proving the theorem, we will apply them to solve questions and we understand what that means. So what that simply means is that we are given a straight line, we are given a circle rather, say with center at this point O, with center O. So if this is the chord, AB, and we said a straight line drawn from the center of the circle from this point to bisect a chord which is not a diameter is at right angle to the circle. So how do we prove this? So we'll see what we can do. So we are given a circle with center O, we have AB here. So that we have that we're given a circle with center O and chord AB. So these are chord AB, such that AB is equal to AM rather is equal to MB. So M here is the center of the chord. So we say that AM is equal to MB. So we are trying to prove that this particular line drawn is at right angle. That means this point here is 90 degrees. So we'll see how we can prove that using our circle theorem. So to do that, I'll draw my circle again. Just for emphasis with center O. I have the straight, I'll draw the chord AB, and I have the line from the center here to point here, which is M, and this is the center here, which is O. So I'll find that I said AM is equals to MB. I'll do a little bit construction. I'll do a little bit of construction. Before I do that, let's say we are trying to prove that AMO is equal to BMO and equal to 90 degrees. This is what we are trying to prove. So we will make a little bit of construction. What is the construction here? We'll join OA and OB. OA and OB. Join OA and OB. So this is OA. We use broken lines for that. So join OA and OB using broken lines. That's the construction. So to be able to prove this now, after doing that construction, the first thing we'll look at is, we know that OA is equals to OB. What's the reason for that? Simply because that's the radius of a circle. Of course, a line from the center of the circle to any point on the circle is called the radius. So from here to here is the radius. From here to here is also the radius. So we have radii. That's the reason for that. OA is equals to OB. The reason for that is because that's the radius. So we also see that AM is equals to MB. So we have AM is equals to MB. What's the reason for that? It was given. We told that we're drawing the line such that a straight line from the center of the circle touches the chord, so that AM here is equals to MB. Having done that, we also see that OM is equals to OM on both sides. So we have OM is equals to OM on both sides of the triangle, or both of triangle O here, triangle AMB and triangle BMO, whichever way you look at it. So we are trying to prove that AMO is equals to BMO, so that's our major objective. So having done that, we also try as possible to bring our circle to view. Looking at our circle critically, there are some things we can get from there. We'll see that AMO is equals to BMO. AMO is equals to BMO in terms of the angle. Angle AMO is equals to BMO. Why? Because OA is equals to OB, OM is equals to OM, and AM is equals to MB. So therefore angle AMO is the same thing as angle BMO. Having done that, it therefore means that we can say angle AMO is equals to angle BMO. The reason is because all three sides are equal. Having done that, we now know that but AMO plus BMO is equals to 180 degrees. So we are referring to this angle here, AMO, BMO. So the whole of this angle here is 180. And what that simply means is that we have it as 180 degrees. The reason for that is angle on a straight line. Angle on a straight line. Having done that, we can now say, since both of them are the same thing, AMO is the same thing as BMO. If we use S to represent this, and also S to represent this, we see is equal to 180. So that we have 2S is equals to 180. S is equals to 180 over 2. That gives me 90 degrees. So that I can see AMO is equals to BMO and is equals to 90 degrees. So we have been able to prove that a line drawn from the center of the circle to bisect a chord is at right angle to this chord.